Okay, here's an example where it was just simply asked to two different questions. Find the integral from 0 to 2, so straight away as soon as we see that we know we've got a definite integral going on, so there's no plus c, of x squared minus 1 dx, and then find the area under the curve, same curve, y equals x squared minus 1 from x equals 0 to x equals 2. So let's just do it one at a time. So the only thing we need to know, and we're going to do a table of integrals a little bit later, is that the integral of x to the n dx is equal to x, you add to the power and divided by that new power. Now if there is a number in the front there, it just stays at the front. And you know if it's an indefinite integral, we've got to add c there, okay, which is just a constant term. So you add a power on the power, any coefficient just stays there. Alright, so if we're going to do the integral between 0 and 2, as I say, no plus c of x squared minus 1 dx is equal to, this is the first one we look at, and that'll be x to the power of 3 over 3 minus, and the integral of 1. Now 1 is equal to x to the power of 0. Anything raised to the power of 0 is 1. So if we add 1 to that power, we get x to the 1 over 1. So that'll be x to the 1 over 1, or just simply x. We wrap some square brackets around that, and we go from 0 to 2. Now it's a matter of substituting in the upper bound first, which is 2. So that'll be 2 cubed on 3 minus 2. Put brackets around that, always subtract, and then we put in the lower bound. So that'll be 0 minus 0. 0 cubed over 3 is just 0. And when we work that out, that's 2 to the power of 3, 8 on 3, which is 2 and 2/3. 2 and 2/3 minus 2 is simply 2/3. So that's the integral from 0 to 2 of x squared minus 1 dx. Question B asks for the area under the curve, and we've already alluded to the fact that integral actually helps us calculate the area, but we've got to be very, very careful, because if we were to graph this, y equals x squared minus 1, well, y equals x squared goes down like that, and minus 1 simply moves y equals x squared down to minus 1, and we get a graph that looks like this. So that's y equals x squared minus 1. And we want to integrate between 0 and 2. Now is 2 here, or is it here or here? So we need to know where that intersect is there with the x-axis. And to do that, x-intercept is when y equals 0. So we've got 0 equals x squared minus 1. This factorizes to x minus 1, x plus 1. And we get x equals 1 or negative 1, where it cuts the x-axis. So this must be our 1, and this must be equal to our negative 1. So we want the area between 0 and 2. So that's 1. 2 is going to be way out here. So I want this area here and this area here. Now, integration calculates that as a negative quantity. Anything below the x-axis it calculates as a negative quantity, and it calculates that as a positive quantity. So when you add a negative and a positive, you use your rules and you get less than this here. So that's not going to calculate the area. So how do we do it? How do we calculate this and make it into a positive and then add it to that? Because you know that area has to be always positive. So what we can do is integrate between 0 and 1, and that'll give us the area down here, and then find the positive of that, and then find the area between 1 and 2, and that'll already be positive. So the area equals the integral from 0 to 1 of x squared minus 1, the integral between 0 and 1. Now that's going to give us a negative because it's below the x-axis, so we need to take the absolute value. The absolute value just gives us the positive of it. And then we're going to add to that the area from 1 to 2 of x squared minus 1 dx. So that will be positive, so we don't need to put the absolute around there. We've already seen, we'll put the absolute there again, we've already seen that the integral of x squared minus 1 is x cubed on 3 minus x. And that'll be between 0 and 1. So I've integrated that and just put these two bounds. Plus, when I do this one over here, it's just x cubed on 3 minus x. And that's between 1 and 2. Put the 1 value in first. And you get 1 cubed, which is 1 on 3 minus 1 when you put in 1. And when you put in 0, it's always the first one minus the second one. Put the 0 in for the second one and you get 0 minus 0. So I've put in the 1 into that and it's minus putting 0 into that. Plus, now we do the 2 in first. So that's 2 cubed, which is 8. On 3 minus 2, so putting in the 2 value gives us that. It's always minus, then putting the second one, so that's 1 on 3 minus 1 equals, now 1/3 minus 1 is minus 2/3, plus, now this is 8 on 3 minus 2, now that's 2 and 2/3, minus that is 2/3, minus, so this is 2/3, minus 1/3 minus 1 is minus 2/3, minus minus is a plus, so that's plus 4/3. Okay, but before we do this calculation, what is this doing? With this here, minus 2/3 is the area from 0 to 1, so it has actually calculated the area down below as minus 2/3. Doesn't know it's calculating area, it just says numerically the integral is negative 2/3, which is fine. So we're taking the absolute value of that. It has taken the area above as 4 on 3, so this is positive 4 on 3. And you can see that if you just put negative 2/3 plus 4 on 3, you get 2 on 3, which is our answer up there. But because we're interested in an area, we've got to take the absolute value plus 4 on 3, which is 6 on 3, which is equal to 2. Very different answer to what we've got up there. All right, so that's integral. Big difference between calculating that. Now that may have its uses that you want to do that. But when we were interested in area, you've got to see if the graph cuts in the domain that you're integrating over. In this case, it does. If it doesn't, you just actually calculate the area, do a straight integral just like you did up there, if the graph doesn't cut in the middle of the domain. Okay, so let's leave it at that.